start video. Okay, let's pass on the methodology of experiment. We rotate the chain on the wheel and throw it on the surface. We record the chain motion on the slow motion camera and investigate this by the video. Okay. This we can see video of the phenomena. And let's watch one more video when chain jump. Okay, we can divide the chain motion on the two stages, acceleration and deceleration of the mass center, as acceleration and deceleration. Okay, and as we can see, there are oscillations in the, during the chain motion, and sometimes we can observe jump. In the framework of research, we would like to give answer to the following questions. How do the oscillations affect the chain mass center motion? What is the acceleration mechanism of the chain? What is the deceleration mechanism of the chain? And why is the chain stable? And why does it have such big life period? And why does the jump appear? And what contribution does it give to the distance walk? The chain motion is very complicated because it consists some parts, and we consider separately each of parts.
Let's investigate the motion of the center of mass. We evaluated the video, each frame of the video, using the edge detection method by performance mathematical. We found the center of intensity, and each was the same as the center of the mass. Here you can see the example of evaluation. And here is our results. On the right graph you can see our own experiment, and you can see that the motion of center of mass is just forward, and there are no oscillations in the motion of center of the mass. So we decided to solve if our own experiment really correlates to the video from the task. And we can see, we evaluated the video from the task, and we see really the results are qualitatively the same. So our effect is the same from the task. And so we can divide chain motion into two separated motions: the motion forward and the oscillation of fishing line. We investigated the motion of the center of the mass. We can divide it into three main stages: the stage of rapid acceleration, the stage of almost constant velocity, and the stage of slow deceleration.
Let's go to the acceleration mechanism part. It's obvious that the center of mass of the chain accelerates under the influence of friction force. At the same time, the tangent velocity of the chain has to decrease. Tangent velocity is the chain speed around the fishing line. And the question appears, does only the friction force have impact on tangent velocity decrease? And let's watch the chain behavior on smooth and rough surface. This behavior on smooth surface and this rough surface. As we can see, the chain center of mass on the smooth surface accelerate slowly compared to raw surface, and lifetime of the chain is the same. We conclude that dry friction isn't main reason of tangent velocity decrease, and since the viscous friction in the system is small, we conclude the main reason of tangent velocity decreases is non-elastic collision of beads on the surface. And the dry friction force has small impact on it. Okay, let's move to the detailed description of this process. Let's consider the momentum of the bead that flies down on the surface, and divide to the horizontal and vertical component. Each beads make an elastic collision with surface and loses the vertical momentum component. And the horizontal component is safe, and these beads accelerates by the tension force, and we wrote down the tangent velocity equation for the acceleration stage. As the reaction force, we have defined as beats momentum change, and this reaction force, and knowing the friction coefficient, we can find friction force, and we can write the second Newton's law, and as we see, the chain accelerates when mass center velocity is less than horizontal projection tangent velocity.
2 minutes left.
Let's discuss the contact angle. We assumed that it is constant, and here you can see the results of the mean contact angle with chain length. We can see that if the chain becomes longer, the contact angle becomes smaller. Here you can see why it happens. This happens because of the process of deformation of the chain. The short chain deformates faster than so does the longer chain. Here you can see, let's go to the distillation mechanism. The kinetic energy of each bead completely lost when it collides the surface. And now let's discuss the chain stability. Really, the tensile force adds the additive tension. The rotating adds the additive tension to the force. That's why the chain is stable. Here we can write the condition of the chain to fall. And let's go to the mechanism of deceleration. We can see that when the bead falls down, it loses its velocity. And here you can see the results from our equations. We can see that that there is quite good agreement with our theory. And let's go to the conclusions. The chain center of mass moves forward. The oscillations of a chain's fishing line make us think the chain walks. The behavior of the chain on surface differs from the behavior of the wheel because of inelastic collisions. The shorter the chain, the further it walks with an equal initial tangent velocity, and we manage to construct the theory that quite well describes the behavior of the chain. Thanks for attention.
Thank you.